For this first check your understanding, let's try to figure out the ordered pair rules for translations and scale changes in amplitude, period, phase shift, and vertical shift for this given graph. First thing you want to do is pick a parent function, either sine or cosine. I will tell you, when you have all four things going on in a graph, the sine graph tends to be a little bit easier to write. Cosine is very doable too, so if you want to go with that one, that would be fine. But what I'm going to do here is actually choose sine. So the first thing I'm going to do is actually draw the parent function for the sine graph, knowing it goes from 0 to 2 pi and makes that S shape. So that is what one rotation of the sine graph looks like. Again, I'm now going to take this one complete hump from 0 to pi and then from pi to 2 pi and mimic that in this shape. I do see that same shape right here. It's going to start here and end here. There's my top hump, and then there's the bottom one. So based on that, I'm actually going to do the ordered pair rules first. I am going to look actually at what the period would be. So if I take a look at this, the period again is typically from 0 to 2 pi. I can tell the period here is from 0 to 4 pi. So based on that, we can actually jot that down. So for the period is going to be 4 pi. Now the period is related to the horizontal stretch or shrink, so that's going to be this component right there. So this is one though you have to be careful. What was the horizontal stretch or shrink? Keep in mind the initial period is normally 2 pi. They did something to it and they got 4 pi. What did they do to this? I can solve this equation if I need to and just divide by 2 pi. And if I do that, I can tell that the x stretch on there was 2. So for this part of the ordered pair rule, it is 2x, and that's when the period comes into play. Now, let's look at another element of it. Let's look at the amplitude. To do the amplitude, the easiest way is to actually look at the complete distance, the vertical distance from the high point here to right down in here. So if you do that, you're going to be able to tell that the high point here is about, if we look at my tick marks, if that's 1, this is a half, so it's at a negative 1/2, and it's going to come down to here at negative 1 1/2. So the complete distance here is actually 1. So again, negative 1/2 to negative 1 1/2, the complete distance is 1. So amplitude would say, to do the amplitude, we're going to take that complete distance of 1 and you're going to cut it in half. So the amplitude is 2. Again, another way to think about amplitude is if you were to draw a line kind of through the center and you see the nice balance here on the top and the bottom, how high is each hump? You can tell here that this hump height is half a unit tall and this one is half a unit. So the amplitude is 1/2. Now, where in the ordered pair rule is that? It is a vertical stretch or shrink. In this case, you could write it one of two ways. You could do 1/2 y, or if you wanted to, you could also write this as y divided by 2. That would be acceptable. So we have our stretches and our shrinks identified. Now, let's look and see how it slid. What I'm going to do for that is I'm going to take the initial starting point right here at the origin, and notice it slid here. I do like using the sine function for this because it's easy to tell that this starting point slid down 1 unit. So sliding down 1 unit is going to be our vertical shift. So I'm going to say down 1 unit. Now in terms of our translation rule, I'm just going to bring this over here. Down 1 is going to be for the y's. So it's going to be this right here. Now the last part of it is going to be identifying what the actual phase shift is. So phase shift is right or left movement. So if I take a look at that, and we notice this point, it did not move right or left. So the phase shift, there was not a phase shift. So what I'm going to do is just put x in its place. And for the answer for phase shift is I will just say none or 0. Okay, now that we have our ordered pair rules, what I'm going to go ahead and do is I'm going to take this ordered pair rule and this one, and I'm going to put it into our parent function. Now again, we chose the sine parent function, so I'm going to take the sine equation. And remember, it's always going to be backwards for x activity. So in here, this x actually got 2 times bigger, and this is the ordered pair rule. This is not the equation. The equation is something you type in your graphing calculator. So the x is backwards. It did get 2 times bigger, so in the equation, I'm going to divide that by 2. And then that takes care of that component. The y value is just what we see, so I can write the y one of 2 ways. I can just put the 1/2 right out front here, or I could divide the whole thing by 2. I'm just going to put the 1/2 right out there. And then this y activity here is -1. So I am going to put some parentheses around this, again, just to make sure it stays clear that it's separate, and put the y, or the -1 there. There is no phase shift for this one because we chose a sine function, and therefore our final answer is going to be this as our equation. Keep in mind you also could write a cosine function for this one, but if you do cosine, the reason I actually did not choose that one, just so you can see, is I'm going to show you the cosine would be this shape of the C. I did not choose cosine because when I noticed that, I would realize that there actually is a phase shift and a vertical shift. And to keep it more simple, I liked sine because it just had a vertical shift and I did not have to deal with a phase shift. So hopefully that helps.